In 1912, former U.S. President Theodore Roosevelt offered a $1,000 prize at the Bronx Zoo to anyone who could produce a snake longer than 30 feet. Explorers scoured the globe, but the prize went unclaimed. Today, we know the biological limit of the modern world's largest serpents, the reticulated pythons and green anacondas, maxes out between 20 and 28 feet. But if we roll the clock back 66 million years, the rules of biology were different. When an asteroid struck the Earth, the apex predators that had dominated the food chain for millions of years simply disappeared. This mass extinction initiated the Paleocene epoch. For 10 million years, the planet's tropical ecosystems began the long process of rebuilding themselves in a world entirely devoid of dinosaurs. The sudden absence of large predators at the top of the food chain created a massive evolutionary opening, priming the environment for a new kind of apex predator to take control. The evidence of what filled that void is buried deep in northern Colombia, inside the Cerrejón coal mine. These massive industrial operations constantly remove millions of tons of topsoil, unintentionally exposing fossil-rich layers from the deep past. In 2003, an undergraduate student tramping through the coal fields found the clear impression of a leaf on a piece of sandstone. These impressions provided the evidence that the America's earliest tropical rainforest grew exactly where the mine stands today. The scale of discovery quickly moved beyond botany. Within those same coal seams, researchers began uncovering turtle shells the size of dining tables and ribs belonging to reptiles that defied modern proportions. Among the haul were massive individual vertebrae. Because of their sheer size, researchers initially assumed they belonged to an extinct species of giant crocodile, yet the anatomical shape was all wrong. This mystery forced the investigation out of the Colombian mud and into a Florida lab. Once there, experts realized they weren't looking at a crocodile, but a creature of entirely different, terrifying proportions. Inside the university lab, reptile specialists recognized the distinct spinal ridges immediately. The vertebrae belonged to a boyd snake, the same lineage as modern boa constrictors and anacondas. Curious, analytical tone. Because snakes grow longer by adding more vertebrae, up to a point, scientists can map the specific shape of a single vertebrae to find its exact position along the spine. By graphing those coordinates against modern snake anatomy, they can mathematically calculate the total body size of the extinct animal. The math revealed a monster, Titanoboa cerrejonensis. It measured up to 48 feet long and weighed an estimated 2,500 pounds. Snake skulls are made of delicate bones that rarely survive the fossilization process intact, but later expeditions managed to uncover Titanoboa skull fragments, definitively confirming its identity and revealing a jaw structure that could extend wide enough to consume massive prey. The thickest part of its body reached as high as a man's waist. A snake of this dimension would literally have to squeeze its sides just to fit through a standard office doorway. Carrying around 2,500 pounds of muscle and scale comes with severe physical constraints. On dry land, the sheer force of gravity would have pinned Titanoboa down, exhausting its energy and potentially crushing its internal organs under its own mass. Its evolutionary solution was water. Operating as a fully aquatic ambush predator, Titanoboa used the buoyancy of the swamp water to maneuver its immense bulk seamlessly, effectively becoming weightless. And the ancient rivers were heavily stocked. Titanoboa shared the waters with 7-foot-long lungfish, armored turtles the size of manhole covers, and early crocodilians spanning up to 15 feet in length. When the snake struck, it anchored its recurved teeth into its prey and coiled its body around them. It applied 400 pounds per square inch of constricting pressure, cutting off blood flow and suffocating even the largest armored crocodiles. This specialized killing machine moved past the simple survival of the dinosaur extinction to seize the absolute top of the Paleocene food chain. But the sheer existence of a 48-foot snake introduces a strict physiological question. How could a cold-blooded reptile amass that much biological material without violating the laws of physiology? This visualization maps ambient temperature against maximum reptilian body mass. Reptiles cannot regulate internal heat, so their size is dictated by their environment. During the Paleocene, atmospheric CO2 spiked 50. The apex predator crown was passed down to smaller, more adaptable reptiles, and eventually to warm-blooded mammals. Modern paleontologists use the Cerrejón fossils as biological proxy data. These remains allow climatologists to model exactly how global temperatures and carbon levels shifted millions of years ago. Titanoboa functions as a deep-time biological thermometer, demonstrating how dramatically a shifting global climate dictates the extreme limits of life on Earth.